All right, guys. So what we're doing today is we are continuing on with chapter 3. We started it before fall break, and we're going to continue on with it today. Now, what we've done so far in chapter 3 is factor. That's the main thing we've done. We've factored. So we started off with factoring quadratics. We spent 3 days kind of looking at the different types of quadratics, different setups we can have. Then with 3.2, we went over special quadratics, so our difference of perfect squares, our ax squared minus b squared, or a squared minus b squared is our a plus b times a minus b, and how we factored those. We also went over zero product property. Zero product property stated that if two things multiply together to equal 0, one of those two has to be 0. And what we're doing today is going over some more ways to be able to solve quadratic equations. So a quadratic equation in one variable in standard form is our ax squared plus bx plus c, where a, b, and c are real numbers and a is different than 0. Now a root of an equation is a solution of the equation. So we can use various methods to solve it. Now out of the 3 listed here, the one we've done already is solving quadratic equations by factoring. We've solved by factoring. That's the one method that we've done. Now we're going to look at the other 2 today. And the first one we're going to look at is graphing, solving quadratic equations by graphing. Because when we graph it, we're trying to find what values of x are going to make the y value be 0. Because when the y value is 0, that x value is where it crosses the x-axis. It's our x-intercepts. So when the function crosses the x-axis, it tells us what value of x is going to make the y value be 0. So the first big thing with solving by graphing is to either get the equation as y equals or get it equal to 0. We want to get the equation equal to 0 before we graph or do most of our solving methods. So as we look at this here, x squared minus x minus 6 equals 0. This one here, the equation is already equal to 0, so we can graph it. So we want to grab the graphing calculator and turn it on. We want to turn it on. After you get it turned on, we're going to hit y equals. So we're going to find the y equals button and hit it. Now if there's anything typed in any of the spaces, go on and hit clear, clear it out. So here I have 3x squared minus 9 in the first spot, so I'm going to hit clear, clear it out. Yep. Everybody find y equals. So the next thing we're going to do, so we don't want anything in any of these equations, and I think for all of us here, they're all cleared out. We're going to type the equation in. Now there's a few places where we can type x, or a few ways we can type x. The nicest one is our button next to alpha. So the button next to alpha, the one that has the xt theta n, xt tau n. We hit it, it will give us x. Now our equation wanted x squared. So the next button I'm going to hit is the square, so we get x squared.
No. Oh,
next to it. Minus x minus 6. If we're typing, if we have subtraction minus, we're going to hit the minus if it's the number in front. So if it was, say, negative x squared, we would actually type the negative. We wouldn't type minus. And if we're subtracting two things, we're going to use the minus key, not the negative. We're not going to say x squared negative x, because it will let you do it, but it's not going to see it as those two being subtracted. It's going to see them as being multiplied. Are we able to get this typed in? Hit graph. Yep. So this here is the graph. This is part of the reason I don't put a big emphasis on being able to graph stuff by hand and do the calculations to graph it. When the graphing calculator, we have tools that'll graph it for us. So we all got the same graph, yes? Now again, we're looking for what values of x are going to make the y value be 0. We're looking for where it crosses the x-axis. And we see that it crosses the x-axis in 2 places, yes? One of them is going to be positive and one is going to be negative. Now at this point here, we can count the little hash marks to see what we get. Or go second graph. Second graph. And that will give us a table of values. And again, we're looking for what value of x is going to make the y value be 0. Now looking at this table, one of the x values that makes the y value be 0 is 3. Is there another one? Negative 2. So we're looking for what value of x will make the y value be 0. We're not looking for what value of y will make the x value 0. Yes. For the equation, y equals negative 2 and 3. Yeah. Hit graph. Second graph. So
that wasn't even the same number from earlier.
So scroll up or down. So those are getting bigger negatives, so we might have to go down. Because negative 2 and 3 give us a y value of 0, yes? Do you see those there? Because again, we're looking for what values of x are going to make the y value be 0. The second column is our y values that correspond to the x values. So when x is negative 2, the y value is 0. When x is 0, the y value is negative 6. 0, negative 6 would be the y-intercept. We don't worry about the y-intercept in solving. We want to know the x-intercepts. We want to know the values of x that will make the y value be 0. So our two solutions are 3 and negative 2. Now, if we wanted to check and make sure these work, all I have to do is take these values, so 3, and plug it back in for x, and see if, when I plug 3 into the function, I get a y value of 0. So 3 squared minus 3 minus 6. Well, 3 squared is 9, minus 3 minus 6. Well, 9 minus 3 is 6, and 6 minus 6 is indeed 0. So it tells us that 3 is indeed a solution. We can do the same thing with negative 2. Negative 2 squared minus negative 2 minus 6. Well, our negative 2 squared, negative 2 times negative 2 is going to be positive 4. Our negative 2 is going to be positive 2 minus 6. Our 4 plus 2 is 6. And 6 minus 6 is indeed 0. So our two solutions are 3 and negative 2. Questions on how we did this here? Questions on any of this so far? Huh? Did you scroll up or down? Because in the table you can go up or down. Yep. Because you can scroll up or down on the table, it gives you more than just those set values. Now let's look at the next one. Negative 2x squared minus 2 equals 4x. Now one of the first steps in solving by graphing is getting the equation equal to 0. We got to get it equal to 0. So what's one of the first things we can do in getting this equal to 0? So we need to move stuff either from the left side to the right or from the right side to the left. So what can we do first in getting this equal to 0? Well, not just 4. We can subtract 4x from both sides because 4x minus 4x is indeed 0. Now 2x squared, negative 2x squared, negative 4x, and negative 2 are not like terms. We don't have the same variable attached to all three. So since we can't combine them, we're just going to rewrite it, or we're just going to write it in standard form. Variable with the biggest exponent goes first, second biggest, and then decreasing. So x squared x, constant term. Now at this point here, we have it equal to 0, so we can graph it. So we can grab the graphing calculator and hit y equals. Now we can clear this out. And what we're going to type in is what? Negative 2 x squared minus 4x minus 2. Are we able to get this typed in? Once you get it typed in, hit graph.
Oh, actually, I had second graph.
So the x2, yeah. How do you do it? Yes. Dimensions, hit enter. Hit enter. Hit y equals. So plot 1 got turned on. So we need to turn it off. So hit enter. Yep, then graph.
Don't let me do that.
So you have to put the x in first.
So like that?
So we got to hit x first. Our button next to alpha, we need to get x. And then we can do the square. So it'd be negative 2, then our button next to alpha. So we have negative 2 x squared minus 4x minus 2. Then we'd hit graph. So we need the x. We get the equation, we get the graph. When we say graph, we should get something that looks like this here, yes? Now we see that it does intersect the x-axis. It touches it, but does not cross it. So we do have a solution at that point. Now we can count the hash marks, or we can go second graph. and see what values of x are going to make the y value be 0. And there's going to be one spot for this here, and that x value is -1. So it's telling us that the solution for this here is x is equal to -1. Now, because the graph touched the x-axis but did not cross it, that point where it touches the x-axis is called an even multiplicity. There's an even number of zeros at that point. Here, in our case, there's 2. It's telling us that x is equal to -1 and x is equal to -1. We have 2 solutions at that point. They're the same value, but we do have 2. Questions on this here? Even if we got it and added the 2x squared and added the 2, we'd still get the same value of x. It might look a little different, but we would still have the same solution. Now, if we look at the next one here, x squared minus x plus 12 equals 0. Is the equation set equal to 0? Which means we can go on and graph it. So we can get the graphing calculator and hit y equals. That's going to be helpful to clear this out, to get rid of the original function, or our last function. And we're going to type in x squared minus 8x plus 12. Were we able to get this typed in? What are we going to hit next? We're going to hit graph. And as we look at this graph here, it crosses the x-axis how many times? Twice. And it's on the positive side. It's to the left side of the right side of the y-axis, not left. So that means both of those values of x should be positive. So that lets me know when I look at the table, I should be looking for 2 positive x values that are going to make the y value be 0. One of the values of x that makes y be 0 is 2, and the other is 6. So x is equal to 2, and x is equal to 6. Questions on this here? Questions on anything we've done so far? Do we like graphing so far? We ready for the next one? We have 1/2 x squared equals 6x minus 20. Again, this equation is not equal to 0, so we need to get this equation equal to 0. So what can we do first? We can minus 6x. 6x and negative 6x on the right-hand side becomes 0, leaving us with negative 20. On the left-hand side, the 1/2 x squared and 6x are not like terms. So we'll just write in standard form. We have 1/2 x squared minus 6x equals negative 20. Is it equal to 0 now? No, so what do we have to do now? We'd have to use our opposite operation, so we would add 20 to both sides, because negative 20 plus 20 is indeed 0. On the left-hand side, we'll have 1/2 x squared minus 6x plus 20 is equal to 0. Questions on how we got this equation equal to 0? We feel good with this here. Now what we can do is we can bring the graphing calculator up and hit y equals. Now at this point here, we do want to clear out that previous equation. We hit clear. Now the first thing we need to type in is the 1/2 alpha y equals enter. Alpha, y equals enter. So that gives us the fraction. Then it is minus 6x plus 20. Was everybody able to get the 1/2 x squared minus 6x plus 20 typed in? So everybody got this typed in? Then what do we do next? We hit graph, yes? So where does it cross the x-axis? It doesn't cross the x-axis. There is no value of x. It's going to make it cross the x-axis. So for this here, we say that there are no real solutions. Now, we can't say that there are no solutions because there are solutions. There are values of x that will actually make this function be 0. They're just not real solutions. And we will dig more into that at a later date, later on, about what that actually means, what those solutions are, how we can actually go about finding them. But at this point here, we can just, all we can say is there are no real solutions. Interestingly enough, we could actually have gotten the x squared by itself, or gotten this equal to 0, by subtracting 1/2 x squared first. Which would have told us that 0 equals negative 1/2 x squared plus 6x minus 20. Now, yes, if we're factoring, we're solving most methods, having a be positive is a nicer way to do it. Having the number in front of x squared be positive is nicer. But the nice thing with the graphing calculator is it does not care if the number in front of x squared is positive or negative. The main thing is we want it equal to 0. We want to get it by itself. And if we graph this here, we see that the function's been flipped, yes? Does it cross the x-axis? No, it's still no real solutions. Because no matter how we have it set up, here, really all we did was flip the signs. We really just multiplied by -1. The solutions don't change. The rest of the function, how it looks, changes, but the solutions will still be the same. So we know if we're looking at these non-real solutions, graphing is not going to work. It's just not. It won't tell us what the non-real zeros are. So graphing works for some, not all. Now for this next one here, it is already equal to 0. So we have 4x squared minus 12x plus 9, yes? So let's go and type it in and graph it. Because it is already equal to 0, so we're good there. So we can type it in and hit graph. Are we able to get it typed in? And we get this here. So we can see that it does intersect the x-axis. It looks like it might cross it, or it might just touch the x-axis and go back up. If it's just intersecting the x-axis and going back up, it means that we're going to have a multiplicity, an even multiplicity. 2 zeros, they're going to have the same value. If we go second graph, Well, we knew that that value was somewhere close to positive 1 or positive 2. Do we have a y value of 0 listed here? No. Now, there are ways that we can use the graphing calculator to mess with this. We can mess with the table set and say that I want the x values to go by 0.5 or 0.25 or 0.3331 But knowing that, well, we'd have to actually know what probably where it is on the x-axis. There are other methods that we can use, and some of those, it's helpful, but it's going to give us an approximation. Now, I'm going to show you one of those methods. Second trace. Did we find this screen here? Now, what we're doing with graphing is we're wanting to find the value of x that's going to make the y value be what? 0. Do we see an option for that? Yeah, the second one's 0. We're going to select it. So what we've told the calculator is that we wanted to find out a value of 0. We wanted to find the value of x that's going to make the y value be 0. Now, it needs a little bit of information from us. The first thing it's going to ask for is the left bound. It needs us to pick a point to the left of where it crosses the x-axis. So that little x, we can use the left or right arrows to move it left or right to where it's going to be left of the point where it crosses the x-axis. And once we get into that point, we can hit enter. Really, it started it to the left of the x-intercept already, yes? So once we hit enter, if you notice in the bottom, it changed from left bound to right bound. So that means we need to use those arrows to move to the right of where it intersects the x-axis. And we can hit enter again. So if you notice here, we've got two arrows pointing towards each other, yes? And what's in the middle, in between those points, should be where it crosses the x-axis. So what we're telling the graphing calculator, somewhere between these two spots, there's an x-intercept. It's going to cross the x-axis. Now at this point here, it's asking us, do we want to guess? Do we want to give a guess at what that x-intercept is? At this point, I'm going to just say enter. I'm not going to try to guess. I'm just going to say find it. And I have a feeling you got something close to this here, yes? Negative, or 1.499997 or 1.50003 time, and it went away. But we got something looking like this here, yes? Somewhere close to 1.5. Now, if you notice, it's not giving us an exact value. It's giving us something close, but it might not be the exact value that we want. So it can be helpful, but it might not always be. So integers aren't always necessarily nice values to work with graphing or with these calculators. But let's go back to factoring. Let's factor this. So if we're solving by factoring, the first thing we need to do is get the equation equal to 0. We're already there. Second step for solving by factoring is greatest common factor is our first real step in factoring. And there is no greatest common factor between 4x squared, 12x, and 9. So we'll move on to our two sets of parentheses with 3 spaces. Since the third term is positive, our signs are the same and match the sign of the middle term. So we'd have negative and negative. If the third term had been negative, the signs would have been opposite. Now we want to find the factors of the first and third terms. Now 4x squared, the x squared's only factors are going to be x and x. Now our factors of 4 are 1 and 4 or 2 and 2. 1 and 4, 2 and 2. Which one do we want to try first? 2 and 2. Factors of the third term, we need to find the factors of 9, which is 1 and 9 or 3 and 3. Which one of these do we want to try first? 3 and 3. And before we move on, we do want to make sure we do have the correct set of factors, so we're going to check our middle term. 2x times negative 3, 2 times negative 3 is going to be negative 6x. Negative 3 times 2x, negative 3 times 2 would be negative 6. We still have our x. Negative 6x minus 6x, negative 6 minus 6, negative 12x. Is that the middle term we wanted? Yes. So it tells us that 2x minus 3 times 2x minus 3 are the correct factors for our 4x squared minus 12x plus 9. Now, according to the zero product property, since we do have two things multiplied together to equal 0, one of these two factors has to be 0. Either 2x minus 3 is 0, or 2x minus 3 is 0. So for the one on the left, we can add 3 to both sides, telling us 2x is equal to 3. Then we would divide by 2, telling us x is equal to 3/2. We can do the same thing with the other 2x minus 3. We can add 3 to both sides, telling us 2x is equal to 3. Divide both sides by 2, telling us x is equal to 3/2. So when I talked earlier about having equations having an even multiplicity, this is what I was saying. Because we do have two solutions, we do have two values of x that make the function be 0. It just works out in this case that both of those values are the exact same number. They're both 3/2. So the calculator was getting us to the correct answer, 1.5. It just had an approximation error. I've had 3 different answers, 3 different values of x that it's given me today on the same problem. So again, there is some calculation, some approximation error. So sometimes it might be nicer to just actually calculate it. Questions on this here? Now the other method that we have for solving is the square root method. Now the square root method works as long as the only variable we have is either being squared or inside of a set of parentheses being squared. If we had a x to the first power, if it had been 4x squared minus 31x, we can't use the square root method. Now the square root method, first step, because we can use it here because the only variable we have is the x squared, is to get the term being squared by itself. First thing we have to do is get the term being squared by itself. So in this case here, the term being squared is x. So we need to get that x squared term by itself. So the first thing we can do to get the x squared term by itself is to what? Add 31 to both sides. And our negative 31 plus 31 is 0. Telling us that 4x squared is equal to 80. Is our x squared term by itself? Oh, we got to get rid of the 4 because we have 4x squared. We need x squared. Because 4x squared divided by 4 is x squared. 80 divided by 4 is 20. Okay, questions on step 1. Now step 2 is part of the reason why this method for solving quadratic gets its name. Because what method are we using? We're using the square root method, yes? Well, our second step, once we get the term being squared by itself, we're going to take the square root of both sides and add the plus or minus, because whenever we take the square root of both sides, we have to put the plus or minus. And we'll go on and put step 3, solve for the variable. Normally that variable is going to be x, but we're just going to say solve for the variable. At this point here, we're going to take the square root of both sides. So we're trying to, one, find the square root of x squared. We're trying to see what times itself is x squared. And that would be x equals. We have to put the plus or minus because what x equals could be positive or negative. Now we need to find the square root of 20. So we would look for perfect square factors of 20 and reduce those there. Well, most likely what you're going to do is grab the 30xs, type in square root of 20 and see if it reduces. Now the graphing calculator will only give you the decimal approximation. It will not give you the simplified radical version. So it's going to be a little bit nicer to use the 30xs because it'll tell us that it is 2 square roots of 5. Now the last step is to solve for the value of x, or solve for the variable. Is our variable by itself? Yeah, x equals. So that's it. We'll stop there. We will finish this too.